funky.
Hello you guys, welcome back to the channel, and long time no see. Merry Christmas, Happy New Year, all of that. And yeah, today we're gonna be just going through just like some notes that I took from gravitational force and electrostatic force, and just like the models, and we're just gonna be going through that. So let's just get started with that. Okay, so for electrostatic forces, their forces are equal in magnitude. So basically, the vectors that are going to be representing the electrostatic forces, when you draw them from both charges, should be equal. And they're also going to be opposite in directions, because according to Newton's third law, so they're equal in magnitude but opposite in direction. So that's pretty easy to grasp. And electrostatic forces, which is what these Fe represents, so you know which one I'm talking about because there are notes from both of them. So yeah, the force and distance have an inverse relationship. So as your distance goes up, your force goes down. And if you really think about that, it makes sense. If you put distance in between them, the force is going to weaken, because how I think about it is, if you have two kids on both sides of your hands, and you were trying to pull both of them in, and they were both trying to pull you in opposite directions, I feel like the more distance they put, the more difficult it would be for you to try to pull them in, so the force is going to weaken. If that makes any sense. I don't know, we can kind of think of it that way. So basically, the more distance you have in between them, the more the force is going to weaken. So yeah, the force isn't really going to be able to have impact on it as much, if that makes sense. But also, don't forget the equation, I think, is electrostatic force is equal to K Q1 Q2 divided by D squared. And don't forget the square, because that's very important. So that's why if you were to double the distance, your force would drop to 1/4, and the reason being because of the squared. So your force is actually inversely proportional to the squared distance. So normally, if you were to double the distance, the inverse would be 1/2, but since it's squared, 1/2 squared would be 1/4. So that's why that is that way. And yeah, so now we can move on to the relationship between the forces and charge. And they have a direct relationship. So as your charge goes up, which is represented by Q, your force also goes up. So if you're to double each charge, so you know how you have a Q1 and a Q2, if you're to double both of them, 2 times 2 would be 4. So your force would increase by a factor of 4. And also, that's something important to keep in mind if you're working with the is it called the powers of 1 or the numbers of 1, when you kind of like plug stuff in to see how the relationship works with just ones. It's important to realize that just because you get a 4 doesn't mean that's what your force is going to equal. That's just how much is going to affect your force, if you didn't know that, you know. Okay, let's go up a little bit. So electrostatic force again, regardless of the difference in the type of the charge and the amount of the charge, both objects experience the same amount of force. So again, just kind of going back to Newton's third law, which was like it doesn't matter how much they weigh or whatever, the amount of force that they're going to apply to each other is always going to be the same, but in opposite directions. You feel me? Okay. Gravitational force is only an attractive force, and is also the weaker force of both of them. So between gravitational force and electrostatic force, the gravitational one is the weaker force. And back to that, gravity can only attract objects. You don't see gravity pushing stuff away. You don't see gravity pushing us away from the center of the Earth. So yeah, but electrostatic can do both. It can be repulsive or attractive, so it can push stuff away or it can pull stuff in. So, and it's also a stronger one. Here's my little diagram for gravitational force, and the R represents distance. So you can see that as your gravitational force goes down, your distance is going up. So that's showing you the inverse relationship between both of them. So both of them have an inverse squared relationship with distance. As distance goes up, the force decreases exponentially. So that's something that they both share in common. The distance vector for both should be measured from the center. So there's a diagram, and it showed the distance being directly in between the two charges, and that's not right, because you should draw your charge and measure directly from the center of the charge and not just the distance between the both of them. So that's that. And again, back with the forces, gravitational force is a much weaker force than electrostatic force. And that is it for the notes, and I hope you guys learned something new, and I hope you have a great day. Bye guys.